Okay, welcome back, ladies and gentlemen. So we have school today, obviously, but it's a short lesson, so I'm going to go kind of fast. I have a theory that tomorrow I saw a wind prediction of 17 miles per hour. I did the math on it. That comes out to over 60-degree wind chill with how cold it will be. If there's a 60-degree wind chill, there's a chance that even tomorrow could get called. I wasn't expecting it to be tomorrow. I was expecting Wednesday for sure. But if they really have 60 below wind chill tomorrow, governor probably calls it for the whole state. That way, Dr. Peterson doesn't have to make the call. I'm gonna say something kind of bold here. I think Dr. Peterson would say we're going to school, but I think the governor might say, 60 below wind chill, you're staying home. So anyway, my prediction is 50-50 chance of tomorrow, but almost positive we have Wednesday off. All right, we can all hope. Yes. The wind chill formula is complicated. It's not super intuitive. Like, you're right. It's been changed recently. All right, we have to get on to the lesson for today. So for today, the only real new thing is some wording, angle of elevation and angle of depression, which allows us to give you word problems, and then you do the exact same thing as you did before. It's just going to be right triangles again. It's just now you're going to set up word problems for it. So if I say something like, there's a guy standing on a building, and the angle of depression to the object, you have to know what the heck that means. Okay, so I have to be able to tell you the words, and then you'll be able to set up right triangles in it. It's just like really easy. So it's perfect for a shortened day today. I do have one more thing, since actually it's so easy today. I'm going to teach you one other thing, and that's this topic called bearings versus true bearings. And later, when we get into some really difficult problems, you're going to have to be able to tell, if I say 280 degrees, you have to know what direction that is. By the way, it's really close to 270, which would be zeros here, 90s here, 180s here, 270s here. So if I say 280, that means about that direction. Pretty much west, but a little bit north of west. All right, so anyway, we'll talk more about that in a second. Right now, I want to get back to that angle of elevation, angle of depression thing. Grab this slide right here. Imagine for a moment you're sitting on that park bench. Would you agree a human being's natural viewing is generally straightforward, like you're looking ahead of yourself? Now, if you're kind of a little sad, like depressed, get where I'm going here, to angle of depression, you might be looking down a little bit. Okay, as opposed to if you're kind of in upbeat mood, you might be like looking up and saying, yeah, life is good and the sky's pretty. And anyway, it's really true that our physiology goes with our mood. You can look at somebody. I guarantee you I could put a picture up and you could go, oh, that person's depressed, just by how they look. Okay, and usually you don't say depressed people are looking up at the sky. It doesn't usually go that way. All right, and one more thing. You should ask me about this some other day. There are studies that prove that there are certain power positions that you can put yourself in where it'll change your mood. Because we always think of, well, your mood kind of mirrors how you feel, but you can trick your body to go the other way. I'll give you an example. Try smiling, a great big smile, and be depressed at the same time. It's like really hard to do. They've done studies on making people stand like they're super confident and bold and like, I can take over the world, kind of the Superman kind of thing. You know, like, I can do this. And then it's so hard to take that and be depressed at the same time. It's amazing. They actually found you can change your mood by how you position your body. All right, so enough about that. The only words here are elevation and depression that you really have to understand. And I hope you could see that this person would be looking ahead, but instead they're looking up into the top of the building. That would be called an angle of, take a wild guess, elevation, okay? Now, what if the person was up on top of the building looking down at the person on the bench? Then what do you think that would be? An angle of depression. Okay, and just to clarify, I want to draw one like that. I'm going to make it a little cleaner. Let's say this is our building, and this is our person standing up on top of the building, and they're looking down. If they were looking straight across versus down, and they see this person, like their friend is walking up to the building, they see them coming from a long ways away. Yay, my friend's coming. This Well, there's two triangles here. You can either use this green one, or you can use this red one. And if I say the angle of depression, as in the person is looking down at their friend, is 40, I would like you to guess which one that is. Is it A or B? Don't say it. Which do you think the angle of depression is? If it's 40, is that the A or is that the B? How many of you are thinking the A? Because you are right. That's the one that's the angle of depression. I naturally want to draw my triangle like the B one. That's how I would like to draw the triangle. But then if I want to do that, I just have to adjust though, and I better not put 40 right here because it isn't 40. What would be B? If this one's 40, come on, this isn't that hard. What would that have to be? That would have to be 50. So do you get, if your standard triangle you would always make is like the B triangle, this one I will make black. Now, this triangle here, if that's your standard way of making triangles, be careful when you're doing an angle of depression because it's tempting to just slap the 40 right here. But the angle of depression is actually from looking straight across, you're now looking down, it's this angle. Okay, now let's see if you really caught that. There's a tall building and a shorter building. The shorter building has a pool on top. So it's kind of fun for the person on top of the upper building to look down at the people swimming in the pool on top of the other building. Okay? I'd like you to draw an appropriate triangle that encompasses this situation. The person looked it up on YouTube, or no, on Google probably, and figured out that they are 400 feet higher at the top of their building than that other building is. And the question would be, how far is it to the middle of this pool? If the angle of depression is 60 degrees. Now notice, I didn't draw you a single triangle, but you now have to draw the triangle. But after you've drawn the triangle, it's just the same problems as yesterday. Would you please put in the angle of depression at 60 in the right spot? Pause for a second while you do that. Okay, I can tell you two ways you could have done this, and I'd like you to know both. This one happens to be a 30, 60, 90 triangle, which means you can use that two triangles method. You don't have to, but you can set up a 30, 60, 90, label all the sides and all the angles, 1, 2, square root of 3, like that. And then you can do that A is to 1, like 400 is to root 3, and then that's already solved, and poof, I'm done. That's awesome. That only works, though, because this is a 30, 60, 90 triangle. It's humanly possible I just did that wrong, but I don't think so. Some people are looking at the board like I'm crazy. Can anybody verify they got that answer? A lot of people are nodding yes. Okay, good. Well, here's way number 2 that you could have solved it. And the nice part is it's similar and uses actual trig. Do you notice I never actually wrote sine, cosine, or tangent there? And since this chapter is called trig, maybe I should know this way. Because what if this wasn't 60? What if it was 58? Today's problem, first problem, 58 degrees. So don't want to just assume I'm just going to always use that triangle way. Because what if it changes to 58? Then this triangle's no longer useful, right? Okay, so here's a way. Sine, cosine, or tangent of 60. Well, I go through them and I say sine is opposite of hypotenuse, but I don't even need the hypotenuse, and I don't know the hypotenuse. So for so, ka, toa, there's 2 of them that use hypotenuse that I can't even use. So that leaves it tangent. You could use tangent of 60 is equal to opposite, which is 400 over A. I don't like this as well for this problem because it's more work. The other way I got done in like a few seconds, but this isn't that bad. Tangent of 60 now can be found here. What do you mean there? Well, a tangent is opposite, TOA, opposite over adjacent. So that's root 3 over 1 equals 400 over A. Now, this is the only time where I would say cross multiplying would be logical. And I'd get A times root 3 is equal to 400, and then I divide by root 3. And what do you know? I finally got to the same answer I had before, 400 over root 3. Okay, why am I bringing that up? Because here's a typical question. That used to be a 30-60-90 or 45-45-90, but if it's 46, that all breaks down, right? And let's say I say this side right here is 14. Would you please figure out H using trig? You'll need a calculator unless somebody in here's memorized sine, cosine, or tangent of 46. Write that one down and figure it out using your calculator. You're not writing anything. What? I'm in mode. And I find radians and degrees. You want to be in degrees. It's under mode. Yes, come on up. Have some collateral to take it for now. He's got so little time left. Bring me collateral next time. Okay, Mr. JS, you have done what I would have asked. You drew the triangle. Awesome. And now what if a kid was stuck? Well, first thing you could do is ask the kid next to you, like, how'd you set this up? It's totally okay. I've set it up that way so that you get to know the person across from you and you can ask them, Mr. Y, how do I set this up in your opinion? There is more than one way. What did you do? Sine of. You stop talking. Sine of 14? No. Nope. Sine of. What comes after sine? Hint, you need an angle right here. There you go. Now, I know you may have said it, but I was waiting for you to say it so I could hear it. Sine of 46 is what? 14 over h. There you go. That's the key right there. Now, from here, you need a calculator. Mr. BH, can you tell me what you would do next? I like it. I wasn't expecting you to do it yet, but it's totally okay. And then what were you, using your method, what are you going to do next? I like it. The advantage to your way is that I only have to type it into the calculator once. 14, divide by, sine, 46, enter. And LM, what did you get? Raise your hand if you got 19.446. All right. If you got all the way to the end and you were like, wait a minute, I didn't get that, maybe your calculator's in radians mode. We are supposed to be in degree mode. Happens all the time. If somebody's like, wait a minute, I typed the same thing, and my calculator gives me a different answer than my friend. All right. Yes, sir. Oh, I said degrees. My bad. Sorry. Good call. It is about a h as in a hypotenuse. The hypotenuse here is 19.46, and I never even said what the units are. Could be miles, inches, feet, whatever, but it's a distance. Good point. Okay. Any questions about angle of elevation, angle of depression, or setting up right triangle problems? Any of those you want me to go over? Okay. Right this second, if I, standing where I am standing, am going to look at any of you in the eyes, am I using an angle of depression or angle of elevation? Depression. Okay, because normal would be here. I'm looking down because I'm standing taller than you, a power position. All right, and then if I look down at you, do you get that I can make a right triangle out of that? With like a straight line that would go from to over your head, and then it would go down to your eyes, and then from your eyes to my eyes. Okay, so I can make a right triangle out of that. Math teachers are kind of weird. We see right triangles everywhere. All right. So that's typical. Let's look at your homework. I'm going to pause for a second while we find. So here it is. It says required day 1 SL text. Don't worry about that. If you wanted to, there's an online textbook that has some of these questions in it. All right. So anyway, this angle of depression from the top of a building 60 meters high to a swing is 58 degrees. Notice no triangle. If we were going to get picky, which we will later, we'd say how tall is the swing set, because that matters. How tall is the person standing on top of the building, because that matters. But you realize that we'd only throw the answer off a little bit, considering how tall this building is really tall. And although 60 meters, this looks way bigger than 60 meters. Anyway, you're going to be drawing a triangle, and it's going to generally look like this. But I suggested, that you make your triangle not like that. Whoa, there goes that disappearing file again. Yay. Now I'm just going to start up a blank one here. If I had done recover, it wouldn't have recovered it, which is one of the other weird things about it. Okay, so I don't have the problem in front of me, but you guys tell me. There's this option or this option. Of the two, which one actually has the angle of depression where it should be? The blue one. And it is, what was it again? Help me. 58. And then, how tall was the building? So I can put 60 on this red one, but that transfers over to 60 over here, right? Okay, so these aren't that tough. They get tougher, but one day at a time. Thankfully, it really worked out nice. For today, to be a shortened lesson, it's actually also a really easy one. All right, I do have one more thing I want to teach you because I know what's coming. Your assignment is short because there's only 3 problems and then it stops. Correct me if I'm wrong. I'm pretty sure there's only 3 questions and it's done. That's it then. I'm signing all of that. That's not hard. That's 10 minutes of work. And it's very possible you don't have any school the next couple of days. There's a chance. We can all hope. All right, so let me teach you that one last thing then. It's bearings. Please, please don't just go do your homework. This is coming and it's very, very important. Would you draw a big north, south, east, west? And let's see how good you are natively at this. If I said, take a bearing of 80 degrees, that means walk in a certain direction. Would you please draw an arrow from the center to wherever you think a bearing of 80 would be? Like, is it that? Hint, it's not. But something like that. A bearing of 80. Yes. Did I screw up my east-west? Oopsie. Thank you. I do that from time to time. Oopie. West. East. Okay, sorry. 80 degrees. Did you draw your arrow? How about this? Turn your 80-degree arrow my way so I can see that you have drawn it like I asked you to. Not drawing? Okay. All right, good, 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 good. Everybody's getting this right. It goes right here. That's where a bearing of 80 would be. A little less than 90, which would have been directly what? East. Okay, good. Now, can you do the other kind, though? This is the harder kind. What if I say, I want you to go north 10 degrees west? Draw an arrow for that. North 10 degrees west. Draw me a little arrow for that. What direction am I talking about? Turn it my way. Let me see if you've got it. Yup, 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 yup. Everybody's got this. Okay. North 10 degrees west is like that. Okay. The degrees is just on the number. All right. Now you can, and normally we say north or south first, but I have seen it on this book and on our homework slides, and I hope this doesn't mess you up. I don't think it's that hard. What if I say east 30 degrees south. I hope that doesn't mess you up, but we'll see. Tell me where you think that would be. It's the same process. Did you put it approximately there? Raise your hand if you did. Okay, good. Now let's mix the two. That one we just did, what is it in true bearings? True bearings would be like, east would be 90, south would be 180, west would be 270, north would be 0. What's that green arrow in true? Well, hint, it's more than 90, right? Here's 0, here's 90, it's more than 90. How much more than 90? That little angle is 30. So true bearings, it would be 90 plus the 30, 120. Raise your hand if you had 120. Okay, awesome. That's the only other topic I wanted to talk about, because here is another way we get you to draw right triangles. Scrappy the dog starts here, and he runs at 30 degrees east of north, just like that. And he keeps running that way for 2 miles. I'll assume that was a straight line for a second, just imagine. Okay. Then, how far, if he was going to travel back and go straight south first, how far would he have to go straight south in order to get back home? Well, do you get how I just basically made you make a right triangle there? And you knew the angles and a side. See what I mean? It's just the same kind of question again. Just a different way to make you draw a triangle where you know the angles and a side. And if I said, how far south is it? I could call this, I don't know, M for miles that he has to go south or something like that. And then hopefully you would have said, if this one was was it 30 degrees? No, this one was 30, wasn't it? So then that makes this a 60. And this is a 90, and this is a 30, and then I can not even use that one. There, I think that's the angles and the sides, right? So then you could say, everybody, right now, write me an equation using either the 60 or the 30 that has m in it. Hint, sine of 30, or sine of 60, or cosine of 30, or cosine of 60. Will give you an m over 2 or a 2 over m. Who used sine of 60? Raise your hand if you did. Sir, what did you have? You are correct. Who used cosine of, not 60, actually nobody should use cosine of 60. Who used cosine of 30? Raise your hand if that's you. Awesome, what'd you get? Cosine of 30 would be m over 2. Weird. That almost implies that cosine 30 and sine of 60 are equal to each other because they both equal m over 2, right? They are. Sine of 60 and cosine of 30 are equal. I'm going to prove it to you. Watch. Here's the 30, 60, 90, and this is 1, 2, square root of 3. And if I have sine of 60, that's this over this. If I have cosine of 30, that's the same thing, isn't it? Those are called co-functions of each other. Let's stretch you a little bit, see if you can handle this. What would cosine of 20 be the same as? Sine of what? 70, very good. Notice those two angles have to add up to 90. What if I had sine of 10? What's that the same as? Cosine of 80. You're going to learn that later this year, but I just wanted to kind of show you. These two equations are totally right, and they're showing you that sine of 60 and cosine of 30 are equal to each other. And what are they? Well, root 3 over 2. So I could replace this with root 3 over 2, and I could solve my little equation. It's m is equal to root 3. That side, square root of 3. Okay. You've learned everything that you needed to know for the assignment. And by the way, the assignment will not have true bearings on it. I just wanted to give you that intro because otherwise that day is kind of a long day, and now we won't have to spend as much time learning true bearings versus just bearings. And your homework is just those 3 problems. And you have some time. The concept. We finished with more time to spare than we usually do, even on a short day. All right. Get to work. If you need help, come on up and ask.